Hi everybody, my name is Angelbert Morales from E. Rodriguez Vocational High School. Welcome to Week 4, Module 1 in Physics 1. So what are we waiting for? Let's dive straight into today's module in Physics 1. When several forces act on a body at the same time, the effect can compensate or cancel one another. When this happens, Newton's first law predicts that there is no change in the motion and that the body is in equilibrium. This means that the body either remains at rest or moves in a straight line with constant velocity. To understand that clearly, I have here a free body diagram. In free body diagram 1, we have the normal force in the weight. The weight is opposite to the normal force. Therefore, it is at rest. If it is at rest, it is in equilibrium. For the free body diagram 2, we have the box at rest, and then suddenly there's a force 1. Then the box is moving towards the direction of force 1. In this case, there is no inequilibrium. For the free body diagram 3, we have the force 1 and the force 2. The force 2 is opposite to the force 1. If force 1 is equal to force 2, then the object is at rest and it is in equilibrium. Let's go back to the supa. The supa is initially at rest and then a person pushes it. Then the supa immediately starts to move. In this case, the supa is not in equilibrium. Let's have another scenario. The car A is initially in motion. And then car B is very fast in speed. Car B hits car A. In this case, the effect of the force is to change the motion, either in direction or speed or both. So, car A is not in equilibrium. Experiment shows that the body is then in equilibrium. If it is initially at rest, it will remain at rest. And if it is initially moving, it continues to move in the same direction with constant speed. In this case, the forces are negatives of each other. F2 is equal to negative F1. And so, their vector sum is equal to 0. F1 is equal to negative F2. In that case, the resolutions of vector is equal to F1 plus F2. In short, two forces are equal in magnitude and opposite in direction or negative of the other. When a body is in equilibrium, the vector sum or resultant of all the forces acting on it must be equal to 0. Each component of the resultant must therefore be 0. That's why a body is in equilibrium. When equation summation of F is equal to 0 is satisfied, the body is in equilibrium provided that it can be represented as a point, or that all the forces acting on it are applied at the same point. The condition for equilibrium, represented by equation summation of F is equal to 0, is called Newton's first law of motion. Newton did not state his first law in exact these words. His original statement is, everybody continues in its state of rest, or of uniform motion is a straight line, unless it is compelled to change that state by forces impressed on it. And that is it! This is Angelberg Morales saying, thank you for watching, thank you for listening, and thank you for your time. Goodbye!